Okay, now we will discuss about vector product and area. First, about definition of vector product. Vector product different with dot product because the result of vector product is a vector. Okay, so vector product can be written as vector product of A, vector A and B can be written as A cross B. Vector A cross vector B. So vector product also called as cross product. Okay, the result of vector product is a vector. Okay, because this is a vector, so there are two components of the result. The first one is the magnitude and also the direction. Okay, the magnitude of cross product A cross B is written as like this one, the length of A cross B, and equals magnitude A times magnitude B sine theta. Theta is the angle between A and B, vector A and B. Okay, and the direction of the result of A cross B is perpendicular to both A and B. Okay, so like this one, if I have this vector A here and vector B here, for example, then the result of A cross B is perpendicular to both A and B. A cross B here. So perpendicular here and perpendicular here. Okay. And if you have vector A, for example, A1, A2, and A3, and you have vector B, B1, B2, B3, okay, then A vector B, this is vector, then vector A cross B is A1, A2, A3 cross B1, B2, B3. Okay, in dot product, we just multiply A1, B1, A2, B2, A3, B3, and the result is a scalar. But in cross product, there is different pattern because the result also a vector. So this is the result. So vector A cross vector B is A1 times A2 times B3 minus A3 times B2. And then the second is A1 times B3 minus A3 times B1, but negative here. And the third row is A1 times B2 minus A2 times B1. Okay, so because this is negative, I will multiply, open the bracket for the second row. So this is A2 B3 minus A3 B2. This is A3 B1 positive here, and this one becomes negative, minus A1 B3, A1 B2 minus A2 B1. Okay. Maybe you have a question, Miss. Do you have any the easiest way to remember this one, gitu ya? So we can find this pattern. Wait. Okay. If we want to find the first row, the result of the first row, this one, this row, so close the first row here, then multiply, cross multiplication A2 B3 here minus A3 B2. So cross pattern here. Close the first row, cross here, A2 B3, then minus A3 B2. Okay, so that's if we want to find the first row. And then for the second row, then close the second row. So A1 times B3 here, and then minus A3 times B1. But for the second row, we put negative here, put a bracket, then negative. And then for the third row, this one, so multiply A1 times B2 minus A2 times B1. Cross here, A1 times B2 minus A2 times B1. Okay, easy, yeah? Okay, then let's try some examples of questions. Wait. Okay, example 1. Find the magnitude of vector A cross B. Okay, we know here magnitude of vector A cross B is vector A times magnitude of vector A times magnitude of vector B sine theta. We already know the magnitude of A and B, and theta already given here. So, okay, let's answer. The magnitude of cross A and B is vector A times vector B sine theta, or 5 times 8 sine 60. Okay, this is 40, sine 60 is half square root of 3. So this is 20 square root of 3. Okay, so the length of, or the magnitude of A cross B is 20 square root of 3. Okay, and example 2. Find A cross B if the vectors A is 3, -1, and 4, and B is -1, 1, and 5. Okay, so we use this process for example 2 here. Okay, vector A cross vector B is 3, 1, 4, 3, -1, 4 cross -1, 1, 5. Okay, using the process. Okay, wait here. Okay, to find the first row, I will close the first row here, block the first row, and then you can write here -1 times 5. This is 5, yeah, minus 4 times 1, and then for the second row 3 times 5 minus 4 times -1, but don't forget to put negative here. Okay, and the last one was this one. Okay, so 3 times 1 minus -1 times -1. Okay, so here -5 minus 4 is -9, and 15 plus 4 is 19, so -19, and then 3 minus 1 times 1 is 1, so 2 here, so -9, -19, and 2. Okay. Okay, I already told you that I already explained before that the direction A cross B is perpendicular to A and B. So we can check here. This is A cross B. Is it perpendicular to A? And is it perpendicular to B? Let's check. We can check here. -9, -19, 2. We know if two vectors are perpendicular, then the dot product equals 0, right? So this is A cross B. Okay, dot A. 3, -1, 4. Okay, -27 plus 19, and then plus 8. Okay, so -27 plus 27. So this is 0. Okay, because the dot product is 0, so it's proven that, yeah, proven that in this problem, A cross B is perpendicular to A, yeah, and then let's try for A cross B dot B. Okay, -9, -19, and 2 dot -1, 1, 5. Is it perpendicular? Then multiply 9, -19 minus 19 plus 10. Okay, so this one plus this one, this is 10. So 9 plus 10 is 19 minus 19. So this is 0. So prove that A cross B is perpendicular to A and B. Yeah. Okay. Okay, and then go to the next about algebraic properties of vector product. Okay, this is the important thing that you have to know, that if you multiply A cross B, this is not equal to B cross A. Yeah, so you need to know about this one, because A cross B, this is equals to negative vector B cross A. Okay, and the multiplication of a constant K to vector A cross B is equal to A cross KB and equals to K A cross B. And if you have vector A cross vector B plus C here equals vector A, so it's similar like if you open the bracket like this one, yeah, A cross B plus vector A cross vector C. Okay, you can find this rule in Huder book. Wait. Okay, you can find here in Huder book. Okay, and for cross product we use sin. Okay, for dot product you use cos, right? But for vector product we use sin to find the magnitude. So we know that sine 0 is 0, and then sine 90 is 1. So if vector A cross vector B are, oh wait, not vector A cross B, but if vector A and vector B are parallel, so it means the angle 0, right? The theta, because parallel, so the theta is 0. Then A cross B is 0. Why? Because if you have the same direction, A and B, then cos 0 is 0, then the magnitude is 0. So if the magnitude is 0, so there is no result for A cross B. And also if you have the same vectors, vector A cross vector A, so this is the same vector, it's also parallel, then the result is 0 also. Okay, and if vector A and vector B are perpendicular, then the magnitude of A cross B is magnitude of A, magnitude of B, sine 90. You know that sine 90 is 1. So if A and B are perpendicular, two perpendicular vectors, then the magnitude is vector A times vector B. Okay. Okay, so that's some rules that you should know. Okay, you can find this formula also in other book. This one. Okay. Okay, let's try some example. Given that the magnitude of A is 2 and the magnitude of vector B is 5, and A and B are perpendicular, this is the important note that this one, A and B are perpendicular. So the angle is 90, yeah? Then sine 90 is 1. Okay. So because A and B are perpendicular, so the cross product of A cross B, it's just vector A, magnitude A times magnitude of B. Yeah, because this is perpendicular, so we use this rule, or we use this rule. Yeah. Okay, now for A, find the magnitude of this one. I will copy the question here. Yep. 3b cross 4a minus 5b. So using the above rules, 3b 3 vector b cross 4a minus 3b cross 5b. Okay, so 3 times 4 is 12, vector b cross vector a minus 15 vector b cross vector b. Okay, we know that the cross product of the same vector equals 0 from here. Yeah, because both vectors are parallel, or the angle is 0 and sine 0 is 0, and this one also. Yeah. Okay, so it's just 12. Okay. Okay. Then okay, we have to find the magnitude. So the magnitude of this one is the magnitude of 3b cross 4a minus 5b equals magnitude of 12b cross a. Okay, so 12, we know b cross a is magnitude of b, magnitude of a. Because it's already given that b and a are perpendicular, so we just write magnitude b times magnitude a. And sine 90, because sine 91, so it's just magnitude b times magnitude a. 12. Magnitude B is already given here, 5, and magnitude A is 2. So 5, so 5 and 2. So this is 120. Okay, clear ya? Okay, go to the second question. B. Okay. 2a minus b factor cross 3a plus 2b. Okay. So 2a cross 3a plus 2b minus b 3a plus 2b. So first I write here 2a here times the whole across the whole this one, and then minus b cross the whole this one. Okay, and then I will open the bracket, 3a plus 2a cross 2b. So don't forget to write cross yeah, and b cross, okay, wait, cross here. Okay, b cross 3a, and then minus b cross 2b. Okay, and then here 6 factor a, this is factor plus 4 factor a cross b. Okay, then remember here minus factor b cross 3a, we use this rule. Okay, minus factor b cross a can be written as a cross b, so I will write here as plus 3a cross b. Why 3a cross b means? Yes, because if I have cross a cross b, it can be written as minus b cross a. Yeah, so if I have minus b cross 3a, then I can write here as 3a cross b. Yeah, okay, this one also plus 2b cross b. Okay, and then we know that this is 0. This is 0 because parallel. This one also 0 because this is parallel. And this one 4 a cross b plus 3a cross b here cross, okay, vector. Okay, so 7a cross b. Okay, 4 plus 3, 7a cross b. Okay, then we have to find the magnitude. The magnitude of 2a minus b cross 3a plus 2b equals 7, the magnitude of 7a cross b, or 7 magnitude of a times magnitude of b, or 7 magnitude of a is 2 and b is 5, so 2 times 5, so the result is 70. Okay, so go to the next subtopic about areas of triangle and parallelogram. Okay, Okay, you know that the area of triangle, for example, if you have, wait, maybe it's the black one. Okay, if you have this triangle, okay, suppose this is theta, this is a B, this is A. Okay, the vector, so area of this triangle is, you can find the area of this triangle, uh, the length of A times the length of B sine theta over 2, or half of magnitude of B times magnitude of A times magnitude of B sine theta, right? Okay, so because we know that this is A cross B, this is the magnitude of A cross B, right? This is the formula for the magnitude of A cross B. Here, you can find here. Yeah, magnitude of A cross B is magnitude of A times magnitude of B sine theta. So this is magnitude of A cross B. So we can find the triangle area using cross product is half magnitude of A cross magnitude of B. Okay, so this is the area of triangle using cross product. Okay, how about parallelogram? Okay, if we have a triangle like this one, so we know that the area of this triangle is this one, but if I have a parallelogram with this, so it means this is twice of triangle, right? Twice the area of triangle. So if I have this theta and this is A and this is vector B here, then the area of parallelogram is twice of the area of triangle, because there are two here and here. If the angle here is theta, then the angle here is theta. If the length of this base is magnitude of A, then the length of this side also magnitude of A. If the length of this side is magnitude of B, then the length of this side also magnitude of B. So the area of parallelogram is twice the area of the triangle. This one, yeah. Okay, it is same with the cross product of A and B, the magnitude of cross product A and B. Okay, let's find the next example here. Okay, a quadrilateral has vertices A, B, C, and D here, so that the quadrilateral is parallelogram. Okay, I do not know the exact point of A and B in the parallelogram, but okay, suppose A is here, B is here, C here, and D here. Okay, if all of these point is the point of parallelogram, then, or the vertices of parallelogram, then vector AB should be equal to vector DC, right? Okay, let's find AB. This is B minus A, so 3 minus 1, negative 3 minus 4, 2 minus 0. Okay, then DC, C minus D, so 1 minus negative 1, 1 minus 8, and then DC, C minus B. Okay, 7 minus 9. Is it correct? AB, B minus A. Okay, and then, okay, let's check. 3 minus 1 is 2, negative 7, and this is 2. Oh, I think I write the wrong number from the last one. AB, this one, AB, so 3 minus 1, negative 3 minus 4, and then 0 minus 2 here. 0 minus 2 here, sorry. Okay, so this is negative 2. So here 1 plus 1, 2, 1 minus 8, negative 7, and then 7 minus 9 is negative 2. Okay, it's proven that AB and DC are the same factor. Then because this is the same factor, then of course AD will be same as BC. So it's proven that ABCD is parallelogram. Okay, and then go to find the area of quadrilateral. To find the area of quadrilateral, we need to know the angle, one of the angle, theta. Okay, I will find, because I already know AB here, AB is 2, negative 7, negative 2. This is 7. And AD, now I will find AD. AD is, okay, D minus A, so negative 1, negative 1, minus 1, negative 2. 8 minus 4 is 4. And then 9 minus 2 is 7. Okay. Okay, to find the angle cos theta, we use cos product. Cos theta is AB dot AD over magnitude of AB, magnitude times the magnitude of AD. So here we multiply this one and this one, negative 4. Find the dot product, yeah, minus 28 minus 14 over the magnitude of AB is 4 plus, okay, 49 plus 4, and here 4 plus 16 plus 49. Wait, okay, yes, okay, so this is the total is, you can calculate using your GDC. This is 46, you can check is it correct or not, and square root of 57 times square root of 69. So theta is cos inverse of this one. And the result is, using GDC, you can find that the angle of theta is 137.18 degrees. Okay, so because we know that theta is an obtuse angle, so Okay, now we know the actual position A here, because this is the obtuse angle. Maybe the ABCD here, right? Okay, because now we already know the angle theta, so and then AB here. AB, the magnitude of AB is square root of 57, and then the magnitude of AD is square root of 69. Okay, we know that the area of parallelogram is the magnitude of AB, A cross B. So area, we want to find the area, right? Area of the quadrilateral. It means the area of this parallelogram is the magnitude of AB cross the magnitude of AD, right? Or the magnitude of AB cross the magnitude of AD sine theta, or square root of 57 square root of 69 sine 137.18, or this is 42.6 unit square. Okay, this is the very long process. Okay, thank you. Okay, and wait. Okay, this is you can do this exercise 8F as the practice for page 231 from Hodder. Okay, you can try question number 2, 5, 9, 19, 21, 27, and 30, and you can also try the other questions. Yeah. Okay, thank you. Bye.